Honorable Mr. Agung Nugroho, as our lecturer, respect audience. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, thank you for coming to see this presentation. First of all, let's say our praise and gratitude to Allah Subhanahu wa Ta'ala. Because of His grace and blessing upon us, we are given the best condition of our health so we can meet today. Salawat and salam be upon to our Prophet Muhammad Sallallahu Alaihi Wasallam. I'm Intan Agustin as the moderator today. Let me introduce our group. First is Nadila Maulida. Second is Dimas Rafi. The third is Mila Rahayati. The fourth is Muhammad Naufal Nadif. The fifth is Asri Birahmawati. The sixth is Intan Agustin. The seventh is Prastiwi Desi Fitriani. And the first presenter today is Nadila Maulida. They will tell us about the history of X-ray tube. To Nadila Maulida, the time is yours.
Thank you to the moderator who have given me time. Now I will begin the presentation. For the first is history. An X-ray tube is a vacuum tube that converts electrical input power into X-rays. The availability of this controllable source of X-rays created the field of radiography, the imaging of partly opaque object with penetrating radiation. X-ray tubes evolved from experimental Crookes tube, with which X-rays were first discovered on 8 November 1895 by the German physicist Wilhelm Conrad Roentgen. This first generation cold cathode or Crookes X-ray tubes were used until the 1920s. The Crookes tube was improved by William Coullett in 1913. The Coullett tube is also called hot cathode tube, is the most widely used. Until the late 1980s, X-ray generators were merely high-voltage AC to DC variable power supplies. In the late 1980s, a different method of control was emerging, called high-speed switching. This followed the electronics technology of switching power supplies and allowed for more accurate control of the X-ray unit, higher quality result, and reduced X-ray exposure. Crookes X-ray tube from early 1900. The cathode is on the right, the anode is in the center with attached heatsink at left. The electrode at the 10 o'clock position is the anticathode. The device at top is softener used to regulate the gas pressure. Coullett X-ray tube from around 1917. The heated cathode is on the left and the anode is right. The X-rays are emitted downward.
And our second presenter is Naufal. They will tell us about the concept of X-ray tube. To Naufal, the time is yours.
Okay, thanks the times for moderator. Okay, here I will continue the discussion about X-ray tubes. I'm here discussing the concept of X-ray tubes. Next slide. X-ray tubes is only a small fraction of the energy delivered to the anode by the electric is converted into X radiation. Most is absorbed by the anode and converted into heat. The two factors that determine production effective are the voltage applied to the tube cavity and the atomic number of the anode, G. An approximate relationship is, next slide. The main function of the X-ray tube are 1. Cathode or negative electrode, 2. Anode electrode positive, 3. Focusing cup, 4. Rotor or stator, 5. Glass metal envelope, 6. Only 7. Window. Next slide. Okay, that's an explain from me, and it will be continued by Dimas about the working principle of X-ray tube.
The third presenter of our group is Dimas Rafi. They will tell us about the work principle and example of modality. To Dimas Rafi, the time is yours.
Okay, thanks first the moderator. Work principle. Next slide. An X-ray tube consists of an anode and a cathode within a casing that can hold vacuum. The cathode is heated to high temperature, where it starts emitting electrons. This process is known as thermionic emission. A high voltage applied between the cathode and the anode accelerates the emitted electron toward the anode. When this high energy electron interact with the anode, some of the energy is converted into X-ray radiation and some into heat. That's why water cooling is needed to prevent the overheating of the anode. The emitted X-ray radiation consists of two components, Bremsstrahlung and characteristic X-ray. In the case of Bremsstrahlung, the electromagnetic radiation is emitted from the negative electron when its trajectory is changed by positively charged atom nucleus. Next slide. This radiation has a very broad energy range. Its energy and intensity depend on the voltage between the anode and the cathode. On the cathode, filament heating current and on the atomic number of the anode material. Characteristic X-ray, however, have a very specific energy, which strongly depend on the anode material. This radiation is generated when the accelerated electron exit the anode atom by kicking out inner shell electron. In the relaxation process, a higher shell electron move to the vacant spot and the excess energy is emitted in the form of X-ray. The energy of this characteristic X-ray depends on the binding energy of the electron test wide kicked out and the binding energy of the electron that occupied the vacant spot. The generated X-ray leaves the tube through a beryllium window. Beryllium is used as a window material because it don't absorb much of the X-ray as it has a low atomic number. Example of modality. X-ray tubes are devices that produce X-ray radiation which is useful in various applications. In medicine, this high energy electromagnetic radiation is used for imaging your body. In airport, X-ray are used to scan your luggage for prohibited item. X-ray crystallography. Material and structure analysis.
Okay, thank you for all the presenters that have told us about the X-ray tube. And our main point today is about the history, concept, and work principle of X-ray tube. And if you have questions, you can ask to us if we have a Zoom meeting on the next meeting. And the questions will be answered by Mila, Asri, and Prastiwi. Once again, thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.